So we led up to this by talking about what parabolas look like, quadratics, what they look like. And I want to just remind you a little bit of that. So let's see if you remember this stuff. If I got a U shape, what's that dotted line down the middle called? Axis of symmetry. What's that spot at the bottom called? The vertex. What's this spot called? The what? Close. Y-intercept. Yes, that's the Y-intercept. What if I made one that was upside down and went through here? Those are called the X-intercepts. All right. So there's some just basic review of your quadratics. Then we factored them. Let's just do a couple factoring. X squared plus 6x minus 7. I had this come up in pre-calc just today. Everybody try factoring that. So write it down. Factor it out. And in a moment, I'm going to ask you to compare with the person sitting next to you. We do have a few kids absent today. So I'll come around and make sure you know who I'm pairing you with to compare your answer. Here's my one advice. You always do 3 steps. First, you figure out it's x and x. Everybody already has that on their paper. I looked. Well, okay, there was one person who hadn't gone that far yet. Then there's the sign in the middle. Figure out if it's minus, minus, plus, minus, or plus, plus. And then last but not least, you figure out what numbers have to be here and here. Okay. Factor that, compare it with the kid next to you. I'll pause for a second. And x plus 7 and x minus 1, did you say? Then how could you know you were right? Let's say the other kid said, no, it's different than that. How could you prove you're right? Yeah, FOIL it out. First would make x squared. And then I always think it's about the outside and the inside. Because if those two are right, almost always right then. So what does the outside make? Negative 1x. What does the inside make? Plus 7x. And that together makes our 6x. It's pretty rare, but every now and then these last two people have those wrong. But they'll multiply to negative 7 if you did it right. And they do. Yay, there's factoring in a nutshell. Now let's try one that's like that, but it's got a GCF that has to factor out first. 2x squared plus 8x minus 10. I'll pause for a second. Factor the GCF out first. If that stuff underneath the root in the quadratic formula, if that was negative, then there wouldn't be any answer. You can't do square roots of negatives. Do you guys remember that? Square roots of negatives don't exist. They're not real. So there's 3 things this can be. Either this could be negative, and then there will be no answers. Or it's positive, and there will be 2 answers. Why? Because you do plus it and minus it. See how there's a plus minus there? So if the discriminant is, I'm going to make notes for you now off to the side. D is less than 0, no solution. I'd abbreviate solution as SOLN. If D is greater than 0, there's 2 solutions. And if D equals 0, that's the last thing. You're either bigger than it, less than it, or equal to 0. If it's equal to 0, it's something in between no solutions and 2 solutions, so 1 solution. I want you to picture how that would look. So everybody, if I had a graph like this, how many solutions does it have? Hint, solutions are the same as the roots, which are the same as the x-intercepts. How many x-intercepts does that have?
1.
You think of the y-intercept.
Yeah, that would have
2 x-intercepts. How about that kind? 1 x-intercept. How about this kind? 0 x-intercepts. You see the difference? So that discriminant part, the D, which is b squared minus 4ac, if it's negative, it'll do this. It won't touch. If it's positive, you'll get like this, where you'll have 2 answers. And if it's equal to 0, because either you're bigger than 0, less than 0, or equal to 0, it'll have 1 x-intercept. Trucker.
Will it ever have a negative that does?
Nope, sorry. Boom.
Will it ever have a negative that does pass the x-intercept?
Nope. If it's negative, you won't have x-intercepts. All right, so here's an equation. X squared plus 3x minus 4. Now, this one happens to factor, but I don't care. Because I'm just trying to think about what will it have for solutions. If it factors, doesn't that mean that I'm going to have 2x intercepts? Yeah, so let me show you what happens when I do. B squared minus 4ac. Now here's the smart way to do b squared minus 4ac. Empty spot squared minus 4 empty spot, empty spot. I made room to drop in with parentheses the a and the b and the c. What was a in this problem? 1. There's a 1 here that we don't see. That's this one. What's the b in this problem? Ryan, what's the b? Yep. B is 3, so I'm putting it here. And Hazel, what's the c in this problem? So I'm putting it there. Now, at this moment, there's a few kids who are not careful, and there's some kids that are careful. If you are careful, you can finish this and get the number. If you are not careful, you're going to screw up a negative, and you'll get the other number, which is the wrong answer. So are you going to be careful? That's really what it boils down to. Because 3 squared is not that hard. It's 9. Some people say it's 6. They're not careful. It's 9 minus, oh, the kid's not careful again. It's not going to be minus 16. What's it going to be? Plus 16. Final answer? Hello. 9 plus 16? 25. Now, where would that have been in the quadratic formula? Let me just show you. Here's the big picture. X equals negative b. Is that part? No. Plus and minus square root. Have I seen it yet? No. I'm doing it in red. B squared minus 4ac. That's what I just figured out. The b squared minus 4ac, that's 25. All over to a. See how we're just focusing on this part? That's called the discriminant. All right, so if I said that I was a very discriminating wine connoisseur, that would mean I'm very good at like picking out good wines. Do you know that somebody who is super good at identifying a good wine because their taste buds are incredibly good? They're called a sommelier. Have you ever heard of a sommelier before? They're people who can just taste a little bit of wine and go, oh, that's a really good wine. If you can that it's a lot more than that, but if you can pass this test to be a sommelier, then you're going to be making tons of money because of your taste buds. Isn't that kind of crazy? And some people are really good at it and some people aren't. Just like some people are really good at music, like they can just hear music and play it. Other people are really good at art. If you happen to have talented taste buds, a sommelier might be your job. Okay, so this is a discriminant. It's discriminating as in determining what is like what's the difference between having a negative here. What if there was a negative here? There wouldn't be any answers because it'd be square root of a negative. Or what if this was positive right here? Well, then you get 2 answers because you do once with plus that number and once with minus that number. You'd have 2 solutions. And the last thing is it's either positive or it's negative or it's what? Equal to 0. Do you remember how many answers you get then? Because why? Let's talk that through. If I put in a 0 right here, all of this is gone. Why do I only have 1 answer? Because try plussing 0 and minusing 0, and you're going to get the same thing, aren't you? That's why there's only 1 answer. When you get a 0 for the discriminant, it'll just be this. And if you remembered back to a month ago when we taught that, that's the x of the vertex, which means that your parabola looks like this, which means also the axis of symmetry would run right through that one number. Okay, that was a lot, but I just taught you the whole lesson. In theory, I could say, good luck. Here's your homework. I'm not going to do that to you, but let's go through this quick. So the square root of 18, I have no idea. But I know the square root of 16. And what's that? Would you agree this is just a little bigger than 4? Because square root of 18 is a little bigger than the square root of 16. So my answer must be just a little bigger than 4. Can you say that? Yeah, you can say that by saying it's between 4 and 5. Between 4 and 5. Okay, square root of 45. I don't like it, so I change it to square root of what's close to 45 but works. 36 works. What else could somebody have said? What's a little bigger than 45 but works?
49.
Square root of 49. Do you get that's between 6 and 7? See what I did there? In my opinion, the best way to do this is that way. Where you figure out a number smaller than it, figure out a number bigger than it, and then you'll know what it's between. It's between 6 and 7. Hazel, is 92 a nice one? No. What's near 92 that works?
100.
Square root of 100 on the big side, and that would be 10. What's the other one on the small side?
81.
Hint, you can just go back down and go, well, I know the answer is going to be 9. And then you go square root of 81. You're right. See how this one's between 9 and 10? All right, everybody. If you get that, tell me what square root of 20 is between. Don't say it out loud. I know you could. Think of a number bigger, think of a number smaller, and you'll know, oh, it's between 5 and 6, or something like that. That's not the right answer, actually. Okay, do it just like I did. Put a number smaller than it, put a number bigger than it, and then I'm going to ask you to compare again, because I know it's hard to pay attention this long. We're almost done, though. You're going to compare with the kid next to you, the square root that's smaller than it and the square root that's bigger than it. I'm going to pause for a second. I agree. So we go 16 here, and what would that be? 4. So it's between 4 and 5, and the 5 would be 25, and see how those line up nice? And then these line up nice, so the answer is between 4 and 5. 4 point something. All right, I think you get the idea there. So move on. Simplifying this, square root of 45 is 3 root 5. I can't even do that in my head. I mean, I can if I go really slow. So how do you do this kind? You break it into 2 square roots. Would you agree that root 9 and root 5 will make 45? 9 times 5 is 45, right? You see what I did there? And now, with that intermediate step, now it's not that hard at all. Square root of 9 is 3. 3 root 5. Oops, messed up my root 5. Can you make it 2 square roots? That's the key. All right, so let's do one like that. Ready? Square root of 40. No, it's not nice. But I can break it into 2 square roots. Now, you do have choices. Should I use 40 and 1? Oh, that'd be stupid. 36 times something? No, that's not the right way to think. You think, what times what makes 40? Could a kid say 6 times 8? Yeah, but neither 6 nor 8, even though this isn't wrong, these don't work out nice. I'd really not like to just leave it root 6 and root 8. That's not any better than it was. You got it?
4 times.
Root 4, root 10, and why is that better?
4 is the square roots into
2 root 10. You see how he did that? Who also had 2 root 10? Ooh, quite a few of you. All right. One more like that. Ready? Square root of 27. First thing, 2 square roots. I'm telling you, I've done a lot of these. Don't try to think, oh, I think there's a 2 in it. Don't do that. Think 2 square roots. Square root of what and what? Ryan, what do you think? 9 and 3, and then what's the answer then? 3 root 3. And by the way, when you have to type this in on a Schoology quiz, it'll be 3 SQRT3. We don't put a parenthesis around the 3 usually, just that's the simplest we can make it. 3 square root 3, that's how to type it on Schoology. Yes?
With a capital S?
No, good question. I shouldn't have written that so big. Lowercase s. Because this is just one of those general rules, we never use capitals. So that for Schoology purposes, you can always not have to like capitalize. 3 SQRT3. All right. I don't exactly know what's going on with this picture, but I don't like it. But I know that they're talking about how this has got an eyeball. I is a thing that stands for the square roots of negatives. We're eventually going to get there, like square root of 25, but negative. The square root of 25 would have been 5. So this will actually be 5i, which means it's 5, but it's imaginary. So I think that's what they're going for on the eyeball picture, but I guess I don't know. All right. So this is just a reminder of how to do this kind. You see how they broke this up? Into 16 times 3 makes 48. And then that's 4 root 3. 4 root 3. Okay. Let's just have you do one more. 52. What the heck does that break into? Lilo, could you think of anything? I'm thinking is like, does 4 go in it? Because, square root of 4 works nice.
Yeah, it does.
Ooh, 4 does go in it. Okay. You know how you guys can do 4? You split it in half twice. What's half of 52? 26. Split it in half again. So it's 13 times 4. Catch how I did that? If 4 goes in it, you can split it in half twice. So what's the final answer? That's a 2, so 2 root 13. You are correct. Okay, I did that one for you. Everybody do square root of 12. Write down the answer and then turn it my way. Square root of 12. Okay, so this one came out to 2 root 3. All right, I think that's enough practice on that kind. So, why did we do that? Why did we do that? Well, here's what happens a lot. You end up with the quadratic formula, and you end up with something like this. 2 plus and minus the square root of 8 all over 4. How in the heck do you simplify that? One step at a time. See this part here? Everybody simplify the square root of 8. Like 3 root 7, but that's not it. Just do the square root of 8 part. Then rewrite the problem, and I'll help you do it one step at a time. Because see, this is the quadratic formula. X equals negative b plus or minus square root all over 2a. See, it's like the quadratic formula, but sometimes you got to simplify them. I guarantee you on your test, you're going to have something like this. And many people aren't going to be able to do it because they'll think that they got it and it's no big deal. But these are more complicated than you'd think. My honors pre-calc kids, which is for some of you 2 years ahead of where you are right now, I give them the same problem and they can't do it. Some of them can, but a lot of them can't. Because they think it's easy, but it's really not. This part, did you break it up into root 4 and root 2 and therefore 2 root 2? Then you got 2 plus and minus 2 root 2 over 4. And then a really common mistake is that they think that you can just cancel out this 2 and this 4? You can't. Why not? What if I had 5 plus 4 over 5? Could I cancel these two and say the answer is 4? Look at it. 5 plus 4 over 5. Is that really equal to 4? No, you can't cancel like that. If you had 5 times 4 over 5, then you could cancel. So we need to make this a times problem, otherwise known as factor it. Okay, everybody factor the top. Factor the bottom. What do you mean factor a 4? 4 is 2 times 2. If you factor the top, you'd get the 2 to come out, and you'd have 1 plus or minus square root of 2. And on the bottom, you'd have 2 times 2. Anybody in here could have factored 4 into 2 times 2. But I think a lot of people had to have trouble doing the top part. But now that I'm there, Josh, do you know how to finish the deal? I'm really close to done. Yep. You cancel that too. And that's it. I know this doesn't feel like a normal answer. It's because you're getting into more advanced math where your answer has a square root in the middle of it. 1 plus or minus the square root of 2 over 2. Now, would you like to separate it into two problems? Some teachers make the kids write this. 1 plus the square root of 2 over 2 and 1 minus the square root of 2 over 2. I'm not going to make you write those as two separate answers. But do you get it is two things? This is two answers. One of them when you add the root 2 and one of them where you subtract the root 2. So if you can factor it, you should, because look at how fast the answers come out. 1 and negative 3, boom. But what can the quadratic formula do? Same exact thing, except look at how many steps it takes. Just so you know, right there, I counted. It's 16 different things you have to do right. 16. 16 separate chances to screw up. It does simplify down then. After a whole bunch of steps, you finally end up with 6 over 2, which is really 3, and 4 over 2, which is really 2. Wouldn't it have been a lot simpler if you could have factored it at the beginning? And you could have. Could have factored this right away. But sometimes things don't factor. That's why we need the quadratic formula. And last, you can also solve quadratics this way. Just take the square root of both sides and look at how fast this is. But the problem, kids think that the square root of 36 is two things. It's not. The square root of 36 is just 6. So I'm going to show you this one on the side. And this is a really important thing that a lot of teachers don't do. And I know it's important because I've seen it happen so many times. Kids think, oh, square root of 9, it's got two answers. No. The square root of 9 does not have two answers. I square root both sides, and the square root of 9 is just 3. But the square root of x squared is the absolute value of x. That means there's two things that could be x. X could be 3. X could be negative 3 because of the absolute value, because it was being squared. So don't ever say the square root of 9 is two things. It's not. The square root of 9 is just 3.
X is 2 things.
X is two things. Very good. Let's just make sure you get that. If I said x squared equals 81, I hope you know that 9 works. But what also works?
Minus 9.
Negative 9. Does that mean the square root of 81 is negative 9? No, it does not mean that. So if I square root, then I get the absolute value of x is 9. And there's two things that work. X equals 9, x equals negative 9. And I don't want you to think there's two answers for square roots. There's only one. but yet there's two answers because the x can be two things. I like the way you said that. All right, so your homework is going to be about discriminant. It's going to be about, in fact, let's just start it together. Everybody find the Schoology quiz. I'll pause for a second while I pull up the Schoology quiz. Okay, the first question, to find a, b, and c for a quadratic, it first must be solved so the quadratic is equal to 0. Then, for instance, in this quadratic, a is 1, b is 3, and c is negative 7. Did you judge that to be true or false?
True.
I agree. It is true. Number 1's true. A is 1, B is 3, and C is negative 7. Okay, number 2. Find the A, B, and C for the following quadratic. Well, that's not too hard. I'll pause for a second. So I had a student answer, and it was 1 for A. B was negative 6, and C was 9. Okay, number 3. The discriminant is found using b squared minus 4ac and tells you the number of solutions. Seems right so far, doesn't it? Okay. If d is less than 0, there's no real solutions. If d is equal to 0, there's one solution. And if d is greater than 0, there are two real solutions. Do you feel like that's right? I'm seeing some kids saying yes and some kids saying no. Is there some part of it you think might be wrong? How many of you think it's right? Raise your hand if you think it's right. That is almost everybody, and you are right. Number 3 is correct. And the reason I made the Schoology quiz this way is so you'd have it. Like now you can look back at number 3, and there's the rules for discriminant. If d is less than 0, there's no solutions. If it's equal to 0, there's 1. If it's bigger than 0, there's 2. Okay, so that was true. And number 4, find the discriminant. B squared minus 4ac. My opinion, empty spot squared minus 4 empty spot, empty spot. Those parentheses are huge. Beckett, what should go in the B spot?
4.
We're on problem 4.
Negative 6.
-6. And how about in the A spot, Beckett?
1.
Excellent. And how about on the C spot? Yes. Okay. And then negative 6 squared is 36. Minus 9 times 4 is 36. 36 minus 36, 0. Okay, cool. So the answer is 0. But what does it mean, Lydia? How many solutions does it have then if the discriminant is 0? You get one solution. Okay, that's problem 4. I think you get the idea of how this works. You find the discriminant, and if the number is positive, you get 2. If it's negative, you get 0 answers. And if it comes out to 0, like this last one, then you have one solution. Remember, I gave you the key in problem 3. Since problem 3's answer was true, all of those rules there, that's how you tell how many solutions you have. All right, that's all I got for you for today.